Hello, and today we'll be looking at some computer networking questions. So let's take a look at the questions first. What is the difference between simplex and half transmission mode? Now, the difference between simplex and half transmission mode is in the way in which data is sent from one user to the other. So, for a simplex transmission mode, let's say we have two users, user A and user B. The data in a simplex communication can only flow from one user to the other in a single pre-specified direction. So, over a simplex channel, either user A can send data to user B or user B can send data to user A. So if user A is sending data to user B cannot use the same channel to send data to user A. An example of such communication or such transmission can be seen in everyday life in form of TV or radio broadcasting. So the data from the broadcasting station is sent to your TV and radios, but the TV and the radios, which are the receiving end, cannot send back the data to the station. So if we try to define it in a single line, simplex transmission mode allows the flow of data in a single pre-specified direction. Half duplex transmission mode, or the half transmission mode as we know it, it allows the flow of data from either of the two parties, but at a given point of time only one party can send the data to the other party. So again, if we have two users, say user A and user B, both can send data to each other, but at a given point of time, say user A starts to transmit the data at time t and continues to send the data till time t plus 3. So during this duration of 3 seconds, user B cannot send any data to user A. Only user A can send data to user B, and user B would be receiving the data. After this time period is over and user B wants to transmit some data, it can send data to user A, but that would be at the time instant of t plus 4. And from here on till the time user B is transmitting the data, user A cannot send back any data and it can just receive the data. So half duplex transmission mode allows the flow of data in either directions but only one at a time. An example of such transmission or communication can be seen in case of walkie-talkies in daily life, and in computer-based applications. Such communication is usually seen in case when a desktop is transmitting or receiving data to a remote server. There is a third type of transmission called the full duplex transmission. Now, as the name itself suggests, the full duplex transmission allows the flow of directions from both the users and simultaneously. So if you have user A and user B, both of them can send data and receive data from each other at the same time. This becomes possible because both the users use dedicated channels. So at the same point of time, user A can both send and receive data from user B, and user B can send and receive data from user A. An example of such type of communication or transmission is in cell phones, where both the parties can talk and listen at the same time. Now, let's take a look at question 2. Let's try and solve a numerical problem over here. Suppose the size of an uncompressed text message is 1 megabyte. How long does it take to download the file over a 32 kilobit per second modem? Let's first list down the data that is being given to us. So the size of data to be downloaded, let's call it ms, is equal to 1 megabyte, and the speed of download, or the speed of the modem which is downloading the data, let's call that SP, is 32 kilobits per second. Now, first of all, let's remember the notations. So if it says k small b, then it's kilobits, and if it says k capital B, it's kilobytes. This is an important thing to remember. The easiest way to solve this problem is to convert the given data into same units, and then it can be reduced to a simple division problem. So now 1 byte is equal to 8 bits. Again, so therefore 1 megabyte, if expressed in terms of bits, becomes equal to 8388608 bits, right? Because 1 kilobyte is equal to 1024 bits. I'm using here the power of 2 notations for conversion. The speed of the modem is 32 kilobits, so per second, that is. So now if we want to express it in terms of bits, we can say that the speed of download is 32,768 bits per second. So now, since we have our given data in the same unit, the problem essentially gets reduced to a simple division problem. So the time taken to download the file is equal to the size of the data that is to be downloaded, that's 8388608 bits upon 32,768 bits per second, that is the speed of download. For ease of convenience, we can also list down the units, so that's bits upon bits per second, which is equal to 256, and from here we can see that bits and bits gets cancelled, the second goes over here, so the result is 256 seconds, which is a unit of time, which is is equal to 4.2 minutes. That is approximately the time that would be required to download a 1 megabyte text uncompressed text message over a 32 kilobit per second modem. Thank you.